Hello, Intro to Statistics. In this video, we are going to take notes on section 1.1, Statistics, the Science and Art of Data. If at any point you need to pause the video or rewind, please do so. But first, we're going to answer the really important question of what is statistics? What is this class about? And as we kind of alluded to, it is the science and art of collecting, analyzing, and drawing conclusions from a set of data. I often talk about the fact that I love statistics because it's really not just looking at numbers, but it's looking at what numbers say. So it's kind of a combination of a lot of subjects. And in order to talk about this, to collect data, to analyze, to draw conclusions from it, we need some language to speak about our data. So we're going to start with the first two important definitions, which are individuals and variables. Now, individuals are the things that we are gathering data from. An individual can be a person, an animal, a thing from which we gather data. And the data that we gather is going to be known as a variable. Any attribute that can take a different value for an individual. And of course, we need to categorize our variables in a couple different ways. As you see here, we've got categorical variables, sometimes known as qualitative, and quantitative variables. Now, if you think about what those words mean outside of statistic, quantitative, you kind of see the word quantity. In categorical, you kind of see the word category. And those are really good reminders as to what these two things are. Categorical variables assign labels that place individuals into groups. Assign labels that place individuals into groups. For example, if I am looking at you as a class, I could take a variable that would be your hair color. Hair color would group you by hair, right? Some of you are blonde, brunette, redheads, very dark hair. We've got really light hair. We've got really different categories. You assign a label, and that individual is in a group. Quantitative variables are variables that take a number for which it makes sense to find an average. Take a number for which it makes sense to take an average. Oops, average. For example, if I ask you all your age, that would be a number, a quantity, and I could find the average age in this classroom. Most of you are juniors and seniors, maybe 16, 17, 18 years of age. We've maybe got a couple sophomores, I believe, probably 15-ish. And then, of course, me, I've got my age, I'm 30. And so if we look at the average age in the classroom, it's probably going to be about 17. There are, though, and this is kind of important, there are variables that are numbers that aren't quantitative, that it doesn't make sense to take an average for. So not every variable that is a number necessarily is quantitative. A really good example of a categorical variable that takes a number would be your zip code. This is a number, right? We're looking at 53213. And that places you in a location. That's Wauwatosa. That gives us a place, a category. Another example would be if we consider our grade freshman, sophomore, junior, senior, but as a number, right? If you're an 11th grader, you are a junior, you are placed in a group. The next thing we're going to talk about is this definition of a distribution. So if you think about the word, again, in our everyday language, you might think about to distribute pieces of paper, right? When I hand out something in class, I'm distributing it to people, I can't think of another definition in this moment, but we've kind of got a similar thing for statistics. A distribution of a variable tells us what values a variable takes and how often it takes these values. So a distribution is looking at the variable we have and the number of times that variable occurs. A really good example would be the dot plot that you made for the Pepsi promotion. Now, I am making this video before we did that, but your dot plot probably looked something like this. 0, 1, 2, 3, and we have dots above how many winners there were in each sample. So, for example, the values this variable could take, the number of winners, we could have 0 winners, we could have 1 winner, we could have 3 winners, etc. And these dots are representing how often there were 0 winners, there were 1 winner. The distribution of a variable tells us what values a variable takes and how often it takes these values. Let's look at an example. On the second day of a stats course, the instructor gave all 40 students in the class a survey. The data in our table shows the first 10 students on the class roster. Identify the individuals and the variables in this data set. Then we need to classify each variable as categorical or quantitative. Our individuals we're looking at are the people, places, things, objects, animals that the data set talks about. So in this case, our individuals are our 40 students. The variables are all of the things that we collected from them. So their sex, their class, their grade, their GPA, their pulse rate, their dominant hand. All of these values up here are our variables. Last but not least, we have to categorize them as categorical, putting in a group, or quantitative. If you want to pause the video and try this, please do so. Otherwise, let's do it together. So gender, sex is going to be categorical, puts you in a group. Class, also again, puts you in a group. Your GPA is a number, and it would make sense to find an average GPA, so we're going to say quantitative. Your pulse rate, again, is a number, and it makes sense to take an average. Dominant hand puts them in a group, categorical. Number of children in a family is an interesting one. So it is a number, and you can find an average. The average might not be perfect, right? It might come out to 2.5 people, and we know that that doesn't really make sense. You can't have 0.5 of a human, but I would also say it would give you a good grasp on how many children there are in a family. So I would argue this is quantitative. You could also argue it as categorical. Next is homework in minutes last night. Notice in this list, they don't give us a set number of minutes. They placed students into different groups. They were doing 0 to 14 minutes, 15 to 29. So this, even though these are numbers, is going to be categorical, puts them in a group. Hours of sleep is quantitative, and whether or not they have a smartphone is categorical. Number 2 says the ages of the 40 students in this class are shown here. So we're given the ages. Summarize the distribution, what values ages take and how often it takes them, with a frequency table and a relative frequency table. Now, I haven't described to you frequency table or relative frequency table yet, but I have a feeling you will be very much okay with this activity, because what we're really looking for here is just to group these. So the different ages students in this class were, I scan through and I see the lowest being 14, the highest being 18. So my ages are 14, 15, 16, 17, and 18. And if I want to create a distribution, I need to show what values it takes, which I just did, and how often it takes those values. To complete this frequency table, I am simply going to count the number of 14s I see in the table, the number of 15s I see in the table. So I'm looking through, I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or I can write the number 5. This is the frequency with which, how often there was a 14-year-old student. Take a moment, pause the video if you'd like, go through and figure out how many students were 15 years old, 16 years old, 17, and 18. I went through and counted how many students were of each age and got these for my frequencies, how often it happened. One way you can double check that you're correct is we know that there are 40 students. If I sum up all these frequencies, I get 40, so I should feel very happy with myself. Then it asked us to find relative frequency. Relative frequency is looking at that number compared to the total. So we're going to say 5 out of 40. What percent of students, what is the relative frequency with relation to everything else that are 14 years old? 5 out of 40 is 12.5%. Of course, you would calculate that in your calculator unless you have a super math brain, which is great. So take a moment right now again, pause the video if you'd like, to calculate the relative frequency. In this next one, we're doing 4 out of 10, 9 out of 10, 17 out of 10, and again, 5 out of 10. Similarly, with our frequencies, we can check our answer by making sure that these percents add up to 100. We need to include all of our data here, so it only makes sense for these to sum up to 100%, that we have covered everything. Frequency is probably the easier thing to find. You do not have to do as much work, but relative frequency can often give us more information. If I am comparing this to another set of data that doesn't have the same number of kids, it's going to be a lot more helpful to say 10% than to say 5 people, because if the other group has 10 people, then we can't really compare those. It's kind of like comparing apples to oranges. We'll look at this again in class next week, but we have now completed section 1.1.